Hello everybody. This video will deal with the power board and specifically going over the schematic of the power board. It is hoped that you watched the first video on the power board where we went over in general the block diagrams, and just as a quick overview is that when you look at the schematic it looks overwhelming. There's 4 sheets, there's a lot of stuff on this board, but it is really not that complicated. There's basically 4 main parts to this thing. The inputs are the solar panels, and there's 14 of them, so there's 14 identical circuits. And then there's batteries, so there's 3 batteries, so there'll be 3 identical circuits. There's some switches that switch the solar panels onto the main bus and the batteries onto the main bus. And let's see, what else? And we have a watchdog timer and some analogs. So if you just look at this thing a piece at a time, we'll try to make it simpler for you. So let's get started. So let's talk about the solar panel inputs. Well, the solar panel inputs over here, and you see a line and it's marked X plus or XL plus, which means this is on the X surface. It's a deployable and it's got on the left side, sometimes we call them the inside and the outside, or left and right. But anyway, the solar panel produces power that comes in on this lead. The first thing it does, it comes to a resistor divider network. So all this is, and we call this a scaling network, and all this does is scale the voltage down. And this thing scales it roughly 2/3. Whatever the voltage is here, 2/3 of the voltage will be down here. We have to do that because the A to D cannot take more than 3 volts. So if you had 4 volts here, you got 3 volts here, and this goes essentially through a switch down to the analog input on the PIC. So progressing down the line is that voltage power flows in here through this resistor. This resistor here is a very small resistor, 0.05 ohms. So this produces, as current flows in this resistor, produces a small voltage drop. And this is essentially a differential amplifier with a gain of 50. So if we had 1 millivolt over here, we would have 50 millivolts over here, and this goes to the A to D. So there's 14 of these guys. So the power progresses through this small dropping resistor, and it goes, and we show a diode here, but that's going to get removed and placed on the solar panel boards, and it goes to a bus. This bus is the always on bus, and that's one of the 4 main buses on this power system. So just in review, as we have 14 solar panel inputs, we actually measure the voltage, and we actually measure the voltage drop across a small resistor, which produces a signal AN49, which will show up on a switch going to the PIC. So that is 14 of the circuits. Okay, now let me get back to my mouse here, and we'll work on another part of the circuit here. So the next thing we want to talk about is the batteries. And where do we hide the battery drawing here? Yeah, here are the batteries. Okay, so let's go center this up and make it a little bigger. So now let me go back and grab my pencil here. So the batteries come in here, and remember we have 3 of these guys. So the battery delivers power, and again, it goes through the same thing. It goes through a resistor divider network, which is reduces about 60% of the voltage. So we send the battery voltage to the PIC through a switch. This also turns on and off this. This is a little switch to ground, which turns on and off. We want to read the battery voltage, we have to energize this thing first. Alright, so current flows through this resistor, and again we have a small voltage drop, And when the current is flowing in this direction, this voltage drop over here across this op-amp differential amp is positive, and so we can measure the current. If current is flowing in this direction, we reverse the plus and minus leads over here, and now this lead will give how much current is flowing out of the battery. So current progresses along this line, and it comes over here, and this is a switch. This chip here is 2 FETs in series, and we control this switch via the PIC, and this delivers power to the always-on bus. All right, so we have 3 of these things. They're just identical, and there's 3 switches. All right, so now how do we switch the always-on bus onto the main bus? Well, we do that with a switch here. Let me move this drawing down a little bit. Let's see. I've got to go gain control of my mouse here. Let's see. Okay, we have the always-on bus here, and so power comes in here, and again this is a switch, and this switch simply supplies power when this thing is energized, and think of that as just a plain old switch. It's actually a solid state switch. It supplies power to what we call the unregulated bus. So when this switch is energized here via this thing, we now have the solar panels connected to the satellite bus we call the unregulated bus, and if the battery switches are closed, it also puts the batteries on this switch. Now there's 2 additional circuits I want to talk about in this video, and that is this device here, which is the 3.3 volt regulator. So in here the voltage will vary from about 3 to 5 volts. On this side of this device over here, it's pretty constant at 3.3 volts. This device is similar. This is the 5 volt regulator, so we have that same 3 to 5 volts coming in here. At this juncture on the 5 volt bus, we put out a constant 5 volts. So now a quick review. We have 4 buses we've talked about. We have the always-on bus, which is essentially the solar panels and the batteries. We have the unregulated bus, and the difference between the always-on bus and the unregulated bus is a single switch. So when this switch, called switch 1, is activated, the unregulated bus is the same as the always-on bus. The 2 other buses are the 3.3 volt bus and the 5 volt bus, and that's the 4 volt. That's the buses. Okay, I'm going to do another video on the rest of the circuit, so stand by for part 2.
Satellite RX2 rising.